All right, we are going to look at part B of this problem. Shrink my window here a little bit. There we go. Part B of this problem asks you to determine the absolute minimum value of the function on the interval between 0 and 8 and to justify your answer. This is one of the topics that came up in section, I think it was 10.5. It was one of those topics that we kind of briefly rushed, but really hadn't worked on very carefully until we were out of school. You're going to see these somewhere on this AP exam. I pretty much guarantee it. Okay, remember that an absolute minimum or maximum can happen at turning points on the graph. So we have a relative maximum there. That could be where that takes place. We have a relative minimum there at 6. That could be where it takes place. But remember, the relative min or max could also happen at the endpoints of the function. So they say that this interval starts at 0. We could have a minimum value there. It says it ends at 8. By the way, so I've listed that we basically need to find the functional values at the endpoints, 0 and 8. In any possible turning point. That's a plateau point because it levels out and it starts increasing again. 4 is a relative maximum. You know what? Since the graph decreases after that, we know that's not going to be the lowest possible value. So technically, you can check any relative maximums or minimums. But again, I don't really need to check a max to find a relative minimum point. So we need the endpoints and we need to check the relative minimum. And remember, when they ask you for a minimum value of a function. Go back to Algebra 1, the value of the function. We're talking the high point or the low point of the function. We're talking about a y-coordinate, okay? So they tell us a couple things here. Look for initial values, okay? Just like in these velocity problems, just like in the rate problems we did, a lot of times there's an initial value. So we already know that f of 8 is 4, okay? So that could be our lowest value for the function. And actually, the function is increasing to that value. So actually, it's probably not going to be our lowest value, but, could have been. All right, so we know that f of 8 is equal to 4. Remember, in these velocity problems, they would give you an initial position, and you would take the integral of the velocity. Remember, the velocity is a derivative. You would take the integral of the velocity over an interval, and that would tell you the displacement. And then you'd add that displacement to the initial position. And in the rate problems, they'd give you, some amount of snow that was already on the ground, and they'd give you the rate at which snow is falling. And you take the integral of the snow rate over a time interval. That told you how much snow fell in that time period, and you added that to the initial value. Every one of those cases, a velocity, a rate, those were derivatives. You were taking the derivative of the integral over a time period to tell you how much the original function changed over that interval. This is exactly the same thing. We're going to take the integral of this derivative. Remember, they gave us f prime here. We're going to take the derivative of the integral. We're going to take the integral of the derivative over the time period to get the initial value. So we're starting out at 8, okay? We want to get back to f of 0. So at 8, the function value is equal to 4, okay? I want to know, how did the function change from 8? Okay, we're starting at 8. We're going backwards to 0. Okay, and I'm just going to take the integral of my rate. Okay, if that was a velocity, we're moving backwards. Okay, a velocity, a rate, a derivative. They're all the same thing. So our initial value plus our integral over the interval. Now, you need to be careful here. This is backwards. Normally we go from 0 to 8. Okay, and we're going backwards on this graph. We're starting at the end and we're moving in reverse. So remember, if you flip the bounds here, you can flip this to be 0 to 8 if you change the sign. Okay, well, guess what? What's the integral from 0 to 8? It's just the sum of the areas of these regions. And it gave those to you. We don't have to take any antiderivatives or find areas of shapes or anything. So we've got a 7, we've got a 6, we've got a 2. That adds up to 15. You've got a negative 3. That's 12. Okay, but we're subtracting the integral in that time period. So it's going to be 4 minus 12, which is negative 8. Okay, that's our functional value at 0. And then if I want to find the functional value at 6, it's the same thing, right? I'm starting out at an x value of 8, and my function is equal to 4. So we still have the same initial value, okay? I'm going to add the integral of the derivative over the time interval between 8 going back to 6, okay? And if you look here, that area is 7. Okay, if we flip-flop these, that changes the sign. It ends up being 4 minus 7, negative 3. Okay, our minimum value here occurs when x is equal to 0.